Hello everyone, my name is Dan the Tutor, and welcome to Lesson 5 of Algebra 1, where today we're going to be talking about graphing linear lines. Out of everything you learned in Algebra 1, this is probably the most famous thing, because a lot, and really most, of Algebra 1 really revolves around something we're going to talk about today, which is the equation y equals mx plus b. Maybe you've heard of this equation before, maybe you have not, but by the end of today, you're definitely going to be very familiar with it. So first, let's talk about what does linear mean. All it means, as far as you're concerned, linear just means a straight line. That's all it means. So like today, when we talk about graphing linear lines, it means we are graphing straight lines. That's the next fill in the blank. And so the good news is, as far as graphing goes, it doesn't get any easier than graphing straight lines. And honestly, this is the first of many equations that you're going to know in your math career. As a matter of fact, I just finished another lesson with my pre-calculus students yesterday. And what they're doing is they're doing not just linear lines, they're doing scary things like quadratic functions, exponential functions, logarithmic functions, a lot of stuff that you're not going to see for a few years, but this is all the building blocks where we're eventually getting you ready to be the mathematical soldier that we need you to be. So first, let's talk about graphing these functions using a table of values. So in other words, this is the function y equals 2x minus 1. This is a linear line, but you don't really know that yet. So let's just make a table of values and let's plug in some points. For the x values, you can choose any x values you want. How about I choose -1, 0, 1, 2, and 3. Doesn't matter which ones I choose, I'll choose those. And now what I'm going to do is I'm going to plug in x into the equation to see what I get for y. So for instance, y equals 2 times -1 minus 1. That would be 2 times -1 is -2 minus 1. We get -3. So -3 for that first one. Then I'm going to do this with the rest of them. So next I'm going to plug in 0 for x. Y equals 2 times 0 minus 1. That would just be 0 minus 1. So it looks like I get -1 for 0. Okay, next is 1. Y equals 2 times 1 minus 1. That would be 2 minus 1, which would then just be +1. So the next point's +1. 2 more to go. Y equals 2 times 2 minus 1. 2 times 2 is 4 minus 1, which is 3. And then one more. When I plug in 3, y equals 2 times 3 minus 1. That would be 6 minus 1, which is 5. So there, we filled out our table of values, and now if we want to, we can plot it on the graph. Now I know I don't say it here, but each of these grids are one tick mark. So in other words, if I want to graph -1, -3, it would be 1 to the left and then 3 down. So there's that point right there at -1, -3. The next point is 0, -1. 0 on the x, go down 1 for the y. You get that point right there. And then we're just going to keep going. So for instance, 1, 1 is right there. 2, 3 is 2 to the right, 3 up. And 3, 5 is 1, 2, 3 to the right, 5 up. 1, 2, 3, 4, 5. And by the way you can tell that you did the right thing is it should literally look like these dots are in a straight line. So that now, when we connect the dots to form a straight line, it better be at least close to being straight. So, yeah, that's pretty good. Good enough. Any questions on that so far? Okay, good. This is what linear lines look like. Also, one more thing I want you to keep in mind is that there was a pattern here, okay? The pattern was if you go up by x by 1 each time, what was the change in y value? The change in y value was +2 each time. To go from -3 to -1, +2. -1 to +1, +2. 1 to 3, +2. Every time it was +2. And the reason why I want you to realize that's significant is because of this number right here in front of the x. That 2 basically tells us what the pattern is going to be. So for instance, if it's 2x, it's +2 each time. If it was -5x, then it'd be -5, -5 each time. and that's the pattern we're going to use. The other thing you could have said was that the minus 1. The minus 1 is special because that's the starting point. And where do we always start on a graph? You should start at 0. I mean, I know we start at -1, but normally you start at 0. The starting point was 0, -1, and that's because of this minus 1 right there in the equation. And we'll talk about more of that later, but for now I just want to start recognizing the patterns. And we have 2 more examples on the next page, so that hopefully we'll get better and better at it. So here's the next one. Y equals -4x plus 4. Same idea with plugging in values for x. Since it doesn't matter, let's start at 0 this time. 0, 1, 2, 3, and 4. Now let's start by plugging in 0 for x, just like before. Y equals -4 times 0 plus 4. Remember, anything times 0 is just 0 plus 4. And that's going to be 4 for the y. And by the way, the reason why this makes sense is because remember what I just said, that's the starting point. Well, 0, 4 makes perfect sense. Okay, now for the next point. Like we said with the pattern, I'm guessing it's going to be -4 each time. Why? Because it's -4x. It's always the thing in front of the x. But just to prove it real quick, let's say I actually plug in 1. Y equals -4 times 1 plus 4. That would be -4 plus 4, which is 0. And it looks like it does follow the pattern because 4 minus 4 is 0. As a matter of fact, I bet the next point will be another -4, which puts us at -4. Then another -4, which puts us at -8. And then one more -4, which puts us to -12. Now you'll notice for the graph to the right, we actually don't even have enough spaces for all these points. And that's okay, because basically what I want you to do when you're graphing functions and you run out of room on the graph, you just stop there. You don't keep going. You don't add in your own points. I mean, sometimes you do if you're making the graph, but if I'm giving you the graph like this, I don't want you to go off the grid really. So here's what I'm saying. If we have the point 0, 4, that's 0 in the x and then 4 up. 1, 2, 3, 4. We get right there. Then 1, 0 is 1 to the right and 0 up or down. The next point, 2, -4, is 2 right, 1, 2, 3, 4. And by the time we get to 3, -8, that would be 3 to the right and -8 down. You're actually, again, off the grid, so you can just stop there. Don't keep going after that. And now, if I were to connect the line, I pretty much see where it needs to go. It needs to go through these lines, just like that. And by the way, typically when you draw lines like this, you usually draw little arrowheads at the end of each side. I know I didn't do that for the last one, but we can do it now. The arrowheads imply that it goes on forever, because it does go on forever, if we had big enough graph paper. So that's it for that one. Any questions?
Yeah. So, because like we're doing functions, when we're doing a table, like, does it matter if like in the previous one when you had like the 4 and -4 or the -1 and 1, like, does it matter if it's like the same number even if it has like different signs? Because you can't have like the same input for like the output.
Yeah, I think I see what you're saying. So you're saying for the table of values, for the x's, they're all unique numbers. Like for instance, it goes 1 up each time. And you're asking, should the y's also be unique numbers, or can they be repeated? Is that what you're saying?
I'm saying that like there's a unique x, but like, does it matter if like if there's a sign in front of it, like if there's like 2 1s?
I see what you're saying. So you're saying, for instance, this -1 here, is that the same thing as +1? Is that what you're saying?
Yeah.
Got it. Okay. Those are 2 unique numbers. And yes, that means that it's absolutely okay to have 2, like -1, +1. You can have +4, -4. The only one you can't have is +0, -0, because that's the same number.
Yeah. Okay.
Yep.
Thank you.
Good question. Okay, next. Y equals 1/2 x. You'll notice 2 things weird about this one. First of all, the fact that we have a fraction. Not a big deal, but scares a lot of kids. The second thing I would say is that there's no starting point, right? Like normally there'd be a +2 or something there, but there is no +2. It's nothing, right? So here's what we're going to do for this one. And again, to prove that the x values don't matter, I'm going to start at -3, and then -2, and then -1, and then 0, and then +1, okay? Now, for this one, I'm just going to plug in for x like we have been. Y equals 1/2 times -3. And if you remember from last week, I think it was last week where we did fractions, obviously we need to remember how to do fractions. Like how do we multiply these together? Well, remember, you just multiply the numerators together. And I know that -3 doesn't look like a numerator, but it is because -3 is technically divided by 1, if you think about it. So what I'm saying is -3 in the numerator and a 2 in the denominator, because 2 times 1 is still 2. So it looks like the first point will be -3 over 2. If you prefer decimals, that would be -1.5. I do not prefer decimals, so I'll be writing -3 over 2. And I encourage you to use fractions as well, because basically every math class past Algebra 1, in general, we're going to prefer fractions over decimals, in general. Okay, the next point, we plug in -2. Y equals 1/2 times -2. Again, same idea, multiply the numerators together, you get -2. The denominator is just 2, and that's going to reduce to -1. So it looks like -1 is the next point. Now, in case you're wondering what the pattern is right now, I hope you realize it should be +1/2 each time, and I know that's hard to see with the fractions versus whole numbers. I get it. But yeah, that's what the pattern's going to be. So for instance, without even doing any real math, I know the next point is just going to be +1/2, +1/2, +1/2. Can someone tell me what -1 + 1/2 is? The answer is -1/2, and you're curious as to why that is. It's because -1 + 1/2, remember we need a common denominator, so multiply by 2 over 2 there. So that gives you -2 over 2 plus 1 over 2. And then remember, for addition of fractions, you just add the numerators together, so -1 over 2. That's how it's -1/2. And then the next point, -1/2 plus 1/2, I mean, that's just going to be 0. And then 0 plus 1/2, that is 1/2. Okay, so it looks like we have our points on our grid. Yes, we're going to do fractions right now. Absolutely fine. So first we go to -3, -3/2. That would be 3 to the left and 1.5 down. And why 1.5? Because again, 3/2 is 1.5. So it's fine to think of it as a decimal when you're plotting it. That's okay. But when I write it out, I'm going to write a fraction. The next point is -2, -1. That's 2 to the left, 1 down. Right there. Next is -1, -1/2, so 1 to the left, down 1/2. So far it's looking like a straight line, that's good. The next point is 0, 0, right at the origin. And then the last point is +1, +1/2. And again, it looks like a straight line, and if I wanted to keep going, I could. And I could keep plugging in points and getting a better and better line. But I get it, I know what it's going to look like. It's going to look something like that. And again, I'm going to put the little arrowheads saying that it goes on forever. Now there's one more thing I want to mention. Remember what I said earlier about the starting point, how there is no starting point because it's not plus or minus some number? Well, in this case, the starting point was at 0. So in other words, whenever you're missing something right here, like again, +2, you'd start at 2. Basically what we're saying is that you have +0 here because it's missing, and so you're going to start at the origin 0, 0. Any questions there? Okay. So now it's time to give you the secret as to what we've been doing the past 15 minutes, and that is the equation y equals mx plus b. We've been doing it the whole time, we just haven't had a word for it yet. This is called slope-intercept form of a linear line. You don't have to memorize that. What you do have to memorize is the fact that m is the slope and b is the y-intercept. So remember how we were saying m was the number you were going up or down each time, like +2, +1/2, whatever? So that's what the slope is. Now the y-intercept again is the starting point. That will be our starting point. And why do we use the letters M and B? I have no idea. It's not even in alphabetical order. And so I did not make this, but this is what I've been doing since 7th grade. And that was in like 2008. So don't do the math, or else you'll realize how old I am. Anyways, with the slope, the other thing I want to say is we have another definition for slope. And that is the fact that slope is equal to rise over run. This is a common expression you'll hear. Slope is the rise over the run. Now, what the heck does that mean? I'll tell you. Your rise is how far up or down you go. That's what the rise is. And the run is how far right or left you go. So then in this example over here, what I would say is pick any 2 points you want. I'll choose this point right here on the y-axis, and then this point right here where it crosses the grid. Always choose a nice coordinate grid point. What do I mean by a nice coordinate grid? Let me zoom in and show you. So what I'm saying is, I'm saying this right here would be a bad point because it's not on a coordinate grid. But this right here, that would be a good coordinate choice because it's on the lines. So if you can, because it's not always possible, but if you can, always choose lines on the coordinate grid. And now what I'm saying is, how far up did we go from the first black dot to the second? It looks like we went up 2. And then how far to the right did we go? We went right 1. So in other words, since slope is rise over run, up over right, basically, we would say M, the slope, is 2 over 1. In other words, the slope is 2. That's what we're saying. And so you can actually plug that in the equation if you wanted to. The other thing I would say is, what's our starting point? Right there. Starting point, again, at x equals 0. We are starting at -3, I believe that is. Yeah, -3. So in other words, that means B is -3. And so if I wanted to put this all together in a very nice equation, then I would write y equals 2x minus 3 for this line and this line only. And there we go. We just figured out our first equation of a line. And now we're going to do a couple more. Okay, that's what the next few examples are for. As you can see, we're going to be doing the exact same thing. And all you need to tell me is what the slope is and where we're starting at, and then we can tell the equation of the line. So for instance, I already know for this one, we are starting at 2 because it's going 2 up. Okay? And again, you can pick any point you want here. For instance, I can choose this point here and this point up here to figure out the slope. Notice that I'm going up 3 in order to get to there. And it looks like I'm going to the right 3 as well. So it looks like then the slope, M, is going to be rise, which is up 3, divided by the run, which is to the right 3. And that is going to be +1 because it reduces. That means my final answer is y equals 1x plus 2. And as always, I don't know if you knew this or not, but if you have a 1 in front of your x, you don't even have to write the 1. You can just write x plus 2. And that is a better answer. It looks neater. Once you get to a certain point in math, you're going to see no one writing the 1x. They would just write x. Any questions there? Okay, good. Now for the next one, I don't want you to try it on your own because this one's more challenging. Basically what I'm saying is, for this one, if we go, what's the starting point right there? Looks like the starting point is at 1, 2, 3 down. When you're going down, that's negative. So in other words, I'm saying B is equal to -3. B is equal to -3. And now when we figure out the rise over the run, okay, let's choose these 2 points right here, okay? Now, technically, it doesn't matter which point you start at, if you start at the left or the right point. I like to start at the left point and then go to the right point. And the reason why I do that is because we all read left to right, so it makes sense to read the graph left to right. So what I'm saying is if you first look at this point up here and then go down, it looks like you're going down 3. 1, 2, 3 down. And it looks like we're going right 1. That's a 1. So that means the slope m is equal to down 3, which is really negative 3. Because whenever you have down, that's negative. Or whenever you have left, that's negative. And then divided by right 1, so just divide by 1. That's just negative 3. So I've got my m, I've got my b. It looks like this equation is y equals negative 3x minus 3. And by the way, if you started the other point and you went right to left, you would get the exact same answer. You would get negative 3x minus 3. Any questions on that one? Okay. And by the way, what we call this a negative slope. One thing I want you to realize the difference between the left line and the right line. And I'm going to erase this stuff just so you can see it better. The number one thing I want you to notice is that if this line goes up as you read from left to right, this is known as a positive slope. And when it goes down like this, that's known as a negative slope. And we're going to be seeing that a lot today and for the rest of your math careers. Okay, so here's the next one. Again, the next one I'm going to be doing, but then I'm going to let you try number 4 on your own. So for number 3, I would say that B, our starting point, is just 1, because that's where you're starting. You start at 1. And now you have to pick 2 points. Let's choose there, and let's choose this point right there. Oh, and by the way, you're going to notice that every point I've chosen so far has been, one of the points has been the starting point. You technically don't have to choose it. However, it's usually the easiest point to choose, so I recommend it. Now, as you can see, it looks like we're going up 2, and we're going right 3. So what that means is my m is going to be up 2, so positive 2, divided by right 3, so positive 3, and that does not reduce. In other words, our final answer is y equals 2/3 x plus 1. And that doesn't look pretty, but it's the right answer, so I'm going to circle it. Any questions on that one? Okay. Now for number 4, I want you to try on your own. Do the best you can. And you know what to do, basically. So I'm going to give you a minute to do that, and then we will reconvene. And if you're watching the video, just pause it, because I'm going to fast forward this part. And go. And time's up. So first, what's the starting point? Looks like the starting point is at 0, which means b equals 0. And then if we choose another point, let's choose this point right here. I know it's close, but as we can see, it's going down 1 and then to the right 1. And what that means is when we say our slope, it's going to be down, which is negative 1, over right, positive 1. So the slope is negative 1. Which means you can write one of two things. One is you can write y equals negative 1x plus 0. Or you can write it the neat way. And the neat way is y equals negative x, and that's it. Because you don't need the 1, you need the negative, and plus 0 is optional. And of course, if you write this, it's not that this is wrong. It's just that this is not the nicest version. So I like my version better, with y equals negative x. Okay, the next one's going to be a challenge problem. Because as you can see, this is like a horizontal line. Like it's not going up or down or anything. Let me show you what we do. It's the same idea, right? So first you're going to say the starting point is at 3, which means b equals 3. And then you just pick another point. So I'll choose this point over here. Doesn't matter. And as you can see, it's up or down. Well, it's up 0. Think of it like that. It's up 0. And then it's right 3. So in other words, my m is going to be up 0 divided by 3. And 0 divided by any number is 0. Don't be confused with undefined. Undefined is when you have 3 over 0. That's undefined. And we're not talking about that right now. Although you will potentially see that in your Algebra 1 class, but not today. Anyways, what I would say is that y equals 0x plus 3. And like I said before about writing things neatly, if you have 0 times x, that just goes away. So the best answer is y equals 3. And this is actually a very common situation. Whenever you have a horizontal line, remember horizontal means like completely flat, no slope, then you just have y equals the number, like for instance 3. In other words, if I had another line down here that was, let's say, right here, and this was 1, 2, 3, 4 down, well, this graph is y equals -4. No m, no x. And you'll get the hang of that after a while. Don't worry. And then for number 6, I'd like you to try it on your own. And again, I'll give you a minute for that. Okay, time's up. So first thing we say is that the starting point is at -3, which means b equals -3. And then this one's kind of hard to see, but the best point is to choose that one right there, because that's the one on the coordinate grid. It looks like for this one we're going down 1, so I know the slope will be negative, and we're going right 4. So that means my slope m is -1 over +4, which we can write as -1/4. Which means my final answer is y equals -1/4 x minus 3, and there's our answer. Okay, good. Now for the last few here today, we're going to be basically doing the opposite. This time I'm going to give you the graph, and we're going to graph it. Now for these first couple, I'll do, and then I'll let you do the last couple. But basically, if we have y equals 3x, you need to tell me two things. You need to tell me the slope, and you need to tell me the starting point. So obviously, since we don't have anything to the right of 3x, that is when you start at 0. So in other words, I already got my first point, it's at 0. The next thing I'm going to do is see how the slope is 3. Well, we know what that means. It means up 3 and right 1. And you may be wondering, why right 1? Because remember, 3 is technically 3 over 1 as a fraction. So up 3, right 1. Here's what I'm going to do. First, I can easily count up 3. 1, 2, 3, right 1. There we go. But do I have to do it again? Yes. Basically, you want to do this as many times until you run out of graphing room. In other words, another up 3. 1, 2, 3, over 1. There we go. And I can't go any more because then I'm off the graph. Now, of course, there is a negative side as well. If you want to know what the negative side is, you do the opposite. In other words, the opposite of up 3, right 1. The opposite would be down 3, left 1. And that's what we got to do for the other way. So in other words, down 3, 1, 2, 3, left 1. We get that point right there. And then one more time, down 3, left 1, that point right there. By the way, here's an easy way to know if you mess up, because I see students do this a lot of times. They'll mess up at this point, and then they'll go left 1, up 3, and they'll do that, and then they go left 1, up 3 like that. And if you look closely, this looks like a V. Your graph should never look like a V if it's a linear line. So that's how you know if you made a mistake. So luckily I spotted it, I corrected it, and now I can just draw the straight line through these points, just like that. And again, I'll put the tails at the end, both ways, like that. And that's all we're doing for these, okay? Now here's the next one. I'm going to do it again. Y equals 1/3 x plus 2. So for this one, I want you to realize that m is 1/3, which basically means up 1, right 3, no big deal. And we're starting at +2 because of the plus 2 there. So in other words, plus 2 means up 2, just like that. And then up 1, 3 to the right. So up 1, 3 to the right, we get that point right there. Up 1, 3 to the right, we get that point right there. And again, the same thing, but on the other side, it's got to be down 1, left 3. Right there. And then down 1, left 3 gets us right there. And I just got to connect this line again. Okay. So there's that one. So why don't you go ahead and give numbers 3 and 4 a try. Do number 3 at first, then, unpause the video and I'll explain how to do it. And then we'll go over number 4. Number 3 is way harder than number 4, by the way. But go ahead, do number 3. I'll give you a few, just pause the video. But I'm going to I'll show you in a second.
Can I say the answer?
Yep.
Okay. Wait.
Just tell me where you're starting at.
Okay, I'm starting at. So I started at negative 0, comma -4, and
Yep.
then I went 3 down and then 5 left, and then I did.
Oh,
the
no,
same
not
thing
3 down,
except I
5
went
left.
right.
Because if you do that, it's a double negative, right? You just want to do down 3 and right 5.
Oh, okay.
But you're doing good.
Okay.
That was a hard one. Okay, I'm going to continue then. Okay, now let's show you how to do it for number 3. So first we're going to start at -4. So 4 down. 1, 2, 3, 4. And then for the slope, it's -3/5, which is really the same thing as they can't both be negative. So basically, we're either going to write -3/5 or you're going to write 3 over -5. I don't care which one you do, but let's do -3/5. If you use that one, it's down 3, right 5. And if you choose the other one, it's up 3, left 5, which if you notice, that's the exact same thing, but in the other direction. Let me show you what I mean. Down 3, right 5 is 1, 2, 3 down, and then 1, 2, 3, 4, 5 to the right. And then up 3, left 5 is just the other way. It's the negative direction. Up 3, 1, 2, 3, left 5. 1, 2, 3, 4, 5. And so it doesn't matter which one you choose, but you can't give the negative sign to both, basically. Okay, and then the arrow's there, and then we're done. Any questions on number 3?
If it goes through the point anyways, like when you're doing the arrow, why can't you do both of them?
I guess what I'm saying is you can do both of them, yes. But what I'm also saying is you just can't do both. In other words, you can't do -3 over -5. You can't do left 3 down 5.
Okay.
That's what I'm saying.
Got it.
Yep. Okay, so number 4, we have y equals -x plus 1. Again, try it on your own. This one's much easier than the last one. So then now, let's see how to do it. We're going to start at +1 right here, and then it's going to be -x, remember, is technically a -1x. The 1's invisible. And what that means is we can either say down 1, right 1, or you can say up 1, left 1. Basically, you can either say -1 over 1, or you can say 1 over -1. That's what I'm saying with down 1, right 1, or up 1, left 1. You can do both, just don't do -1 over -1. So then down 1, right 1, down 1, right 1. Yeah, this one's got a lot of points. That's okay. And you don't have to go all the way to the end. You can just do enough where you know how to connect the dots. And then same for the other way. Just connect the lines, basically. Up 1, left 1, up 1, left 1. Right foot, left foot. And then finally, connect the lines, connect the dots. And there we go. There's our answer. Now, hopefully that's making sense, because for the last topic of today, we're going to be talking about how to calculate the slope given 2 points. So this right here is probably the most famous formula from Algebra 1, besides y equals mx plus b. It's m equals y2 minus y1 over x2 minus x1. Now the funny thing is, I just met with my calculus students yesterday. Yes, earlier I said I met with my pre-calc students. Well, I met with pre-calc, I met with calc, I meet with a lot of kids. But basically, what I want to say is that in calculus for the summer course, we were basically using this formula, except in a much harder context, which you guys are just not ready for yet. But basically what I want to get to is the fact that this right here is going to be lasting through basically your entire math career. And this equation is the basis for calculus. So you probably have no idea what calculus really means besides the fact that it's just really hard math. Well, basically, if I were to sum up calculus in one word, I would say it's slope. In other words, Today we're talking about slope of linear lines. Well, what if I could tell you that you can find the slope of any shape you want on a graph at any point if I give you a function? That's basically what calculus is. So we're not ready for that yet because you don't even know the fact that this is a cubic function. So how are we going to talk about derivatives and slopes if you don't even know what a cubic function is? So that's why we have to start with linear. And we spend so much time on linear because it's the most important graph out of every graph, at least for students in math. So anyways, you look at this example here, and remember with our coordinate points, you've got basically -2, +1, so -2, 1, which -2 is our x1, 1 is our y1, and I have to call it these names so I can plug it in the formula. Then for the other point, I've got 2 to the right, so 2 in the x direction, and 1, 2, 3, 4, 5 up. Yeah, this is kind of confusing because it's the opposite. Like, in other words, we've been saying rise first this whole day, but now when it's a coordinate point, remember, x goes first, then y. And I know that's confusing, but don't worry. Anyways, x2, y2, x1, y1, we have all the points. So that means I can just plug in this formula here. M is equal to y2, which is 5, minus y1, which is 1. And I'm getting these numbers because I annotated everything, and I recommend you do the same thing for the first few times you do this. Divided by x2, which is 2, minus x1, which is -2. We'll talk about that. So first, 5 minus 1 is 4, and 2 minus -2. That's a double negative. In other words, it's really 2 plus 2, so 4. And so in other words, 4 divided by 4 is 1. There's your slope. And if you want to think of it like this, basically if you were to connect these two lines like this, basically what we're saying is the exact same thing as the slope formula. You're going up 1 to the right 1 each time. Now obviously when I give you this graph here, it's kind of easy to see that, but you're not always given a graph. Let's look at the next few examples. Find the slope between the points 7, 3 and 10, 9. So this is what I'm saying. We need to use the slope formula because you're not always given a graph. So again, I'm going to annotate this. I'm going to say 7 is x1, 3 is y1, 10 is x2, 9 is y2. And so what that means is m equals y2 minus y1 over x2 minus x1. And so that's going to be 9 minus 3 divided by 10 minus 7. And again, I'm just following the formula. So that's going to be 9 minus 3, which is 6, divided by 10 minus 7, which is 3. And we'll get an answer of +2. And there's our slope. Now, by the way, in case you're curious, the direction doesn't actually matter. Let me explain what I mean. So we just had the points 7, 3 and 10, 9, right? So what I'm saying is if you do, this was x1, y1, this is x2, y2. What I'm saying is if you want to instead, if you want to do y1 minus y2 over x1 minus x2, it doesn't matter. We'll get the exact same answer. Let me prove it. So y1 is 3 minus y2 is 9 divided by x1 is 7 minus x2 is 10. 3 minus 9, that's -6, and 7 minus 10, that's -3. You still get +2 anyway because the negatives cancel. So what's the moral of the story? Well, you can choose any version of this you want. If you want my advice, stick to the original form because that's the form that you're going to be most familiar with and you're going to use most of the time. So let's just stick with this form today, but I'm just telling you if you mess up, the good news is it still should work. Number 2, 1, 4, and 2, -5. So again, I'm going to say x1, y1, x2, y2. That means m is going to be -5 minus 4 divided by 2 minus 1. That's going to be -5 minus 4 is -9, and 2 minus 1 is just 1. -9 over 1 is -9. And there's our slope. So why don't you do the next one on your own, number 3. I do want to warn you, it will be a fraction, and if you can't reduce it, just leave it as a fraction. Go ahead and go and unpause the video when you're ready. Okay, now we'll go over number 3. So again, we just have to follow the formula. It's going to be 0 minus 8 over 0 minus 5 That's going to be negative 8 over negative 5. The negatives cancel. We get 8 over 5. And there we go. And then for the last one of today, again, I want you to try it on your own. Number 4. Go ahead. Okay, so here we go. M equals y2, which is 12, minus negative 12. So that is a double negative. It will be a positive. Divided by 2 minus negative 4. Another double negative. So what I'm saying is the numerator is 12 plus 12, and the denominator is 2 plus 4. So we're going to get 12 plus 12, 24, divided by 2 plus 4, 6. 24 divided by 6 is just going to be 4. And there's our slope. And that's it for today. And hopefully you learned something new, or at least you remembered something from the past, because this is one of the fundamental things in Algebra 1. Oh, and by the way, this is one of the most popular kinds of questions they like to throw on the SAT if you're studying for that, because y equals mx plus b, which again is the most important equation we'll learn in Algebra 1, is basically, I don't want to say half the questions on the SAT, but it's over a third. And it's not questions as easy as this, because the SAT likes to make it really hard with the wording of the questions, but over a third of the questions use this equation, is what I'm trying to say, at some point in the problem. So if you're really good at this, then you're going to have an easier time in the SAT. So thank you all for joining me. Hope you have a great rest of your day, and I'll see you next week. Bye-bye.